just a small channel, which is in fact sat on a concrete foot, which is set below the paving, but nevertheless, that is the only structure, the only footings that are required. A glass linkway creates the necessary physical and visual difference between the two structures and is often the stated preferred option. Now, I want to try and swing the next photo in, which I hope is, I should be able to do this. Right, now here we're looking at glass used, and this is stretching the boundaries. This large piece of glass, I hope you can all see my cursor, this large piece of glass at the top here is what's called a laminated beam. Now this, so there is no metal, wood or other physical structure. The roof of this building is held up. There are a number of beams. There's one there, there's one here, and we quite interestingly managed to integrate this beam into this side panel by use of cutting the glass in so that one panel of the beam was missing, and similarly one panel of the vertical was missing, so that they dovetail together, and they're bolted there for structural integrity. So other than the metalwork at the base and these hinges and the metal patch fittings here, which actually join, connect and provide full structural integrity, other than that, the entire structure is glass. I'll just show you the next view. So looking up, you can now see clearly this is what's called a triple laminated beam, and the size and weight of the glass necessary is detailed for us when we design these things, and then we go to the glass engineer, send him the drawings, and he produces these, the specification for this. So he'll tell us how wide it needs to be, what the individual panels of glass need to be, and therefore exactly what the structure of the beam is in order to manage the loading for this entire structure. And essentially, that's how we're able to provide the thing with full structural integrity, and we assemble these and sign them off, and building control's quite happy with what we do, and so on and so forth. So it's all done extremely professionally. Let me see what the next picture is. This is a different one. So moving on to point 2, this is between, this actual installation is in Putney. It's between a very old building on the right and a much more modern building on the left, and we've created a linkway by large vertical panels which are set within the structure, and a number of not quite horizontal, but sloping for drainage, but otherwise there's no physical structure here. Again, glass is designed absolutely and manufactured for full integrity, even in the event of, for example, a 6-foot snow storm. The glass needs to maintain a full integrity and not crack or collapse or anything else. So what I was going to say was, many heritage buildings have a modest footprint, but with high ceilings provide plenty of unused space within the interior. Sorry, I'm reading the wrong thing. Okay. I'm just going to click onto the next photo. Yeah, so I'm going to talk you through this, because this is absolutely connecting the two buildings together in a way which has the least visual impact. So again, as I was saying, there is no physical structure at the joints between the glasses. Literally, these are double glazed, what are called structural units, where they're built not just with spacer bars, but the edges of the units are silicon bonded, so that we use a product called Arbomeric, which is a black rubberized specific roof light sealant, and again, it gives the structure full waterproofing integrity and full structural integrity. So minimal fixings are, apologies, I'll just go back to that. Minimal fixings, we've actually used a steel along the wall to hold the high edge of the glass. It's pinned between two angles and again sealed in place. And then on the low side, this is the low side here, that drains off, and is, you know, water from that is funneled away via the drainage system. Equally, these horizontal big glass windows were originally, they were supposed to be buried within the structure, but when the architect realized that if you buried them beneath the structure and somebody broke one, the only way to get them out and change them is to actually smash the wall down, they decided that wasn't quite such a good idea. So we put our idea, which was to put surface fixings on, which again, a two-piece, still provides a thermally broken installation, but it means that should someone break a window, and indeed someone did, it's possible to change the glass without having to smash the wall down and take it all away. So anyway, moving on now. Right, now this is, I'll just give you a bit of a brief on it. Maximize space without restricting light flow, that's the title. Many heritage buildings have a modest footprint, but with high ceilings provide plenty of unused space within the interior. Creating a mezzanine floor is an obvious solution if you need to increase space, but you'll need to ensure this doesn't make the interior feel dark and oppressive. Incorporating structural glass into the designs will maximize the use of natural light, and this project indeed, in addition to the large top of arch closers, there are glass balustrades and other use of frameless glass throughout the project, which I'll hopefully show you with some more photographs. But our brief included manufacturing these steels, which again were the structural engineer, when we showed him what we were proposing, he gave us the size and weight that they needed to be. And the way these work is that they bolt together in situ. So effectively, it's a T shape. The glass sits into it, and then it has two closing beads which bolt up on the inside. And we manufacture these again to the required size and weight to take the loading. So in other words, if a couple of 30-stone football stars happen to decide to take a running jump at this glass and hit it with their shoulder, the thing needs to stay in place. So they're pretty serious. Installations. They've just got to comply with full loading requirements. So this is looking from the other side, and you can see that there's a substantial drop were this glass to fail. So there just can't be a situation where that were to happen. And indeed, you can also see in this photograph, there's a second screen here with a door in it here. There's also outside that screen, you're then more into the open mezzanine sort of walkway area, and this is a handrail on top of glass balustrade, which is bolted into the substrate here, built into the structure. And indeed, in the background, there's another arch which has been closed in with glass. Down here on the right-hand side, although you can't very easily see it in the photo, there's also a glass porch. So that's the main door. Just in the background there, you can see the line of light around the main door, timber door to the building. But you walk in, and there's a fully enclosed glass porch with a number of doors in it. So this is repurposing of a church which made it into a wellness centre. So several £1 million spent. I was fortunate enough to be involved in the design, working with the architect initially, and then we were awarded the contract for the installation, and so on and so forth. So quite a complex project. Right. Moving on. This and I must confess that our main work, ION's main work, is in historic and heritage buildings, more churches than anything else. This is a project in Bolton-on-the-Water, where the whole of the interior of the church was changed. This timber structure was put in place, and a mezzanine floor was created, where again the balustrades were run around. They have a bolted handrail, so the glass is base fixed. In other words, the structure that holds the glass is buried behind this fascia panel here. So whilst the handrail that's bolted through certainly does give it integrity, nonetheless, the glass has to be manufactured fully in accordance with the required loading. So, for example, probably won't mean anything, but this glass needs to meet 1.5 kilonewtons loading at the top of the glass, which is here 1100 high above the floor. So whilst the handrail does certainly, if you like, spread that load between adjacent panels, nonetheless the glass itself is doing the guarding, and it's very important, obviously, that we get this right. You can see over here on the right hand side, just in the edge of the photo, there's a Juliet balcony, and again, in churches, particularly when you're changing the levels, because the churches were originally obviously designed for only floor level working. Once you start to introduce people walking up close to historic windows, especially ones with great significance, then these Juliet balconies, some of which can be very large, need to be fixed in place, again, full structural integrity, so that should someone fall against it while they're walking up the staircase, or down the staircase indeed, the glass protects them and the stained glass window behind from injury and damage. There's another view of the same project, the other side of this beam, and again, long runs of glass. You can see the congregation here was substantial. So on days when there are significant visitors to the church, again, this effectively needs to meet the glass balustrade effectively needs to meet what's defined as crowd loading. So in the event that there were a number of people who decided for whatever reason to get out of their chairs and push against this thing, the whole thing's got to stay in place, and that's our responsibility to make sure that happens. Again, down below, simple pair of normal pivot doors. Not a lot to say about that. There are several sets of them in the reworked entryway. And another view of the same project, where long runs of glass, bolted handrail. There's quite a degree of difficulty. But one of the things I'm about to talk about, you can just see down here, where the glass is very accurately cut around the stone corbelling, and we have a piece of digital measuring equipment which very accurately scans this in, and it produces engineers amongst you a DXF file which we send to the glass factory, which allows them to cut the glass very accurately to what we want, allowing 5 or 10 mil clearance between the edge of glass and the stonework. So the title of the third part of what I was going to say was to be mindful of corbels, uneven floors, and carved wood. And I'll show you some close-up examples of this. Apologies, this is another project where a lot of glass, a mezzanine floor, several levels of new introduced structure, again where the mezzanine floor has been guarded completely with glass, what we call cantilevered glass, where it's fixed at the base, and this has a timber handrail on it, but again the glass needs to do the guarding. Down below, nothing particularly special about this. It's sliding doors and pivot doors into a completely new area. Again, though, the fixings, in this case, the fixings, you can see them on the surface here, literally channel set glass. Not that exciting. Let me move on. So, this is a slightly different situation. This is a glass bridge inside, or a glass guarded bridge inside a very old barn that's been redeveloped by one of our clients. Excuse me while I just get my notes back up. So here, the client came to see us, told us what he wanted, told us everybody else had told him it couldn't be done. We know that it's perfectly possible to achieve domestic, and in this case, so that's 0.74 kilonewtons loading up here. It's perfectly possible to fix glass balustrades using single point fixings like this, 80 mil in diameter, which are resin anchored back into the concrete floor, and that will meet loading requirements. And you can see in the background where my cursor is now that on the staircase, and I hope I've got another picture of this, right, on the staircase. So you can see on the staircase, this was pairs of 60 mil bolt fixings, and again you can see the way the glass has been scribed. It exactly meets the shape of the concrete staircase underside, which is what the client wanted. So again, we digitally measure all of this, and the glass is made to exactly meet what we need it to. The added complication in this case, of course, is that it's curved glass, and so there's a series of processes involved in making this, and particularly in measuring it and getting it right. This staircase was only 600 mil wide, and structural glass of this size, it's 21.5 mil toughened laminate. Toughened glass of this size can only be built curved to a minimum radius of 700 mil, and that's why these standoffs here are 100 mil long. Again, these were specially made. They've got 16 mil threaded bolts through them, again to achieve loading, because the turning moment is about this point and the fixings are through this point. So in other words, when someone leans on the glass up here, this will tend to pull out and this will tend to snap off. And that's what you've got to make sure in your engineering, that you've taken account of all of those factors. Right, so as I was saying, being mindful of corbels, uneven floors and carved wood, it's wholly possible to fit glass closely around heritage features, but the process involves accurate computer-aided measurements, detailed drawings, careful manufacture and experienced installers. I would say that, wouldn't I? It's worth engaging an experienced glass heritage expert, that's us, to ensure a flawless fit and avoid unsightly gaps. And you can see here just how well the glass, and it actually moves with every nuance, effectively every nuance of the stone. The glass very, very carefully follows the line of the stone. And yes, this is something that my company particularly specializes in. As far as I know, we're the only company in Britain that can do this. So that's why we get to work in a lot of historic buildings. Here's another one. This is actually in Lewes, in Sussex, and again, quite complex stone. Here, the architect insisted that the gap be filled with silicon. Normally, we wouldn't do that because, well, our view is silicon's not a very either sightly nor long-term successful finish, but nonetheless, if that's what the architect wants, that's what he has to have. So, but again, you can see the way the lines of the edge of the glass follow all the nuances of the stone around, and yeah, this is exactly what we specialize in. Same a different part of the same installation, and again, just very carefully cut. The interesting point, and I'll just mention it here, is that whilst it's perfectly possible to cut a sharp corner on the outside of glass, it's not possible to cut a sharp corner on the inside. The tightest corner you can do, like this, is, I think I'm right in saying, the diameter of the thickness of the glass. So in other words, this will be 12 or 15 mil glass, and so this is either a 12 or 15 mil corner. You can't make a sharp corner; it will just explode in the toughening. So that's why every internal corner is radiused like that. And this one, okay, so this is a close-up of the same thing, where again it's not, I can't say much more about that. But the next one, I think, right now, this is slightly more interesting. This is a cutout around a timber beam. The interesting thing about glass is, providing there's a structural anchor this side of the cutout, ditto the other side that you can't see it, we can still meet loading requirements at the top of the glass. So whilst that sounds counterintuitive, in fact, our glass engineer confirmed that it's perfectly possible to take a significant cutout out of the glass without compromising its loading integrity. And that's another photo showing that staircase that we were talking about before. You can see double bolt fixings and the way the glass follows the line of the staircase. This is all very detailed installations that, again, require a great deal of care in both measurement, producing drawings, and the manufacture. So phenomenally complicated project. Right, moving on. This is a close-up of a new glass door in Parsons Green in London. I think that's the original entrance with this slightly foreboding, very dark timber door, which church wardens used to like, and it's been replaced with that. Hopefully, I've got a big scale. I mean, this is in fact a double glazed door. You can see just there, that's the line of the detailing on the inner panel, and this is the line, same detailing on the outer panel, but looked at from an angle, you can see both panes. Perfectly possible to construct the door in such a way that again, it meets all statutory requirements by way of 5, whatever it is, locking pins or whatever. It's perfectly possible to make the door to fulfill those requirements. And there is the entrance. So that's how it did look. And this is how it looks after the fact. And you can see just how much more welcoming that is from the point of view of, not quite from the point of view of the parishioners, because they're already going there, but the non-committed walking past are welcomed in, and this is a view that most church wardens, priests, whoever, have the view that the more we can introduce glass into these historic buildings, the better their more usability and the better their congregation. Moving on, glass doors are visually welcoming. This, in fact, is Cranley School. I think somebody mentioned Cranley during a preamble. This is Cranley School. They commissioned us to replace a number of their external doors with glass assemblies. Once again, you can see that this is an assembly. There's a side panel there set to channel. This is bolt fixed over panel with a number of these spring plates holding that in place, and the whole thing is held together with these structural patch fittings at the top of the doors, and then of course you've got your floor springs down here buried in the ground. So fully compliant, lock in the middle, fully compliant, and you know, 1,000 uses a day or whatever. But certainly this door was fitted 7 or 8 years ago. I think we've been back once to adjust it since then, so they're pretty durable as well. This is a very interesting project. Once again, anybody that knows anything about the engineering of doors working inside non-rectangular openings will know how difficult it is to get doors to work. I mean, the wall here is probably 6 inches thick, and you can't use standard fittings. Otherwise, the glass actually, the pinch point is around here. As the door opens, this actually hits the stone, so you have to use particular type of hinges. But once again, you can see how accurately the glass has been made to fit within the stone. And using these hinges, it works perfectly. Again, Church are absolutely delighted. Here's a set of automatic doors fitted to a church in, I can't remember. Anyway, we fit a lot of, we supply and fit a lot of automatic doors, again, where it's required, and churches are surprisingly big users of automatic doors because they're DEA compliant. So in other words, anybody turning up in a wheelchair can press the button here, doors open for them, in they go, and it's particularly suitable for repurposing when the church is to be used for other than religious purposes, where there may be a requirement for higher disabled use. These are particularly suitable. There's a view of the same doors closed. This is in Soho, St Anne's Church in Soho. Now, what's interesting about this is that although there are patch fittings around the edge of the glass, there are no other visible fixings. And what we did was very I say very cleverly, I would say that, wouldn't I? These are box sections, stainless box sections, where we've had slots cut in the sides of them. So the box section itself, this here and this here, are welded together at this point. But the slots that are cut in them, we then put rubber gaskets in them and literally sat the glass into the slots, bolted it up, and they ended up with something that looked absolutely minimal and was, this was an award-winning project. This was a Churches Conservation Trust award. So we were very pleased with this. We were obviously involved in the design, but particularly the engineering of it, making it work, and so on and so forth. And again, that was fitted probably 5 years ago. This is literally just, now, anybody that knows London, and I know that you will, you may recognise this. This is the Guildhall Church. This is the Lord Mayor's Church. And these are Amaran doors. I haven't discussed it previously, but this is often a requirement by Historic England, because there are a lot of photographs taken. Amaran glass is anti-reflective. It is extraordinarily expensive, but it allows people to come and take photographs from outside without themselves being, each standing directly in front of the door, without themselves being a major part of the photograph. So again, it's a very something that Historic England look for quite a lot. Again, we used, and in fact we had them made, brass cover plates over the rails, top and bottom. We had these are what are called offset pivots, which is allows the doors to close into what's called a reveal. So in other words, it's not an open arch. It has an actual reveal in it, which the glass sits into, which allows it to create a waterproof, not waterproof, but weatherproof installation. And yeah, this is, as I say, this is the Guildhall. And there is the manifestation. I've no doubt you will recognize that. We fit a lot of very interesting manifestations. for the simple and sole reason that it's a legal requirement to ensure that people don't walk into the doors, so they all have to have these sorts of decorations on them, which at least warn people that they're potentially about to walk into something that they don't necessarily see or are aware of. This is Lancing College, and again, this is now entirely spring plate fixed, so it's a glass assembly, over panel, side panels, 2 pivot doors, and again, long timber handles, 1,000 uses a day. And I think in the years that they've been fitted, we've only been back once to adjust them. So they're pretty robust installations, and the floor springs and the upper pivots are extremely robust in terms of long-term serious use. So the last thing I was going to refer to is don't be afraid to be bold with your design. Work with the existing building, but don't restrict your plans to replicating what has gone before. Whilst previous builders may have made use of natural materials such as stone and timber, it doesn't necessarily mean that these are the only options when it comes to extending or renovating. Now this is Nicholas Dimbleby commissioned us to fit this. This is the Dimbleby Cancer Care building, which is part of St Thomas's Hospital. It's the new building about 150 yards up the road from the main entrance. And Nicholas came to see us. Funnily enough, we met him via Cranley School, which he went to when we were doing some other work there. And he asked us to design and build this screen, which is made up of a number of panels. You can see there's one of the vertical lines there. So they're fitted one way and then the other way, and we created this continuous S-shaped, if you like, channel that we had rolled and fabricated, especially for the top and bottom of the glass. Ditto over here, and since then there's been some additional, because they wanted the reception area to be separated off, they put some distressing on the glass. So in other words, a sort of diffuse panel through the middle of the glass so that you can't see what's going on behind it. Now, this is yet another use, and this was the exterior glass porch fitted to the barn, with the heritage barn with the bridge and the curved staircase in it. This is what he asked us to do outside. So we designed this, and it's the slope of the roof exactly marries with the slope of the roof of the barn. Again, these are long glass beams in here, which are bolted to the floor via, I haven't got the detailed photos available, but they have stainless double angles which are bolted through, and then these single panel, these are 5-meter roof panels, which were then laid on and bonded with structural glazing tape. So they actually have no mechanical fixing whatsoever on this structure. And again, it's been there for years. So we have to take into account wind loads and not so much snow loads, because no snow is going to sit on that, but certainly significant wind loading here on the glass ends, and it created a real focal point to the barn. And there's another view of it. You can see the stainless feet here, and Well, although I didn't mention it, the beams are bolted at the top, and at the bottom here there are dovetailed together what are called glass fins. So there's a vertical fin there, and this beam sits over it. So again, this is a triple laminated fin where only the center panel projects, and the beams have that section of their central panel missing, and so the two dovetail together, again assembled with clear silicon and the glass bonded over the top. So again, very successful installation. There's another view of the same thing. And that, folks, is the end of my presentation. So I hope that what I've done is show you that glass per se can be used as a fully structural element, that it can be used and replace both timber and steel, and it really is a highly innovative product which is only now starting to come into its own. So over to you, and thanks very much for listening.
You can unshare your screen.
Okay, how do I do that? Down the bottom?
At the top, probably.
Okay. I can't get it off. Right, there we go. I'm here. So.
Excellent, thank you.
Thank you.
Very good.
Very good indeed. Absolutely fascinating.
It's a fascinating product. It really, seriously is a fascinating product. And, you know, with the right design and the right engineering, it can be used in some very, very interesting ways.
No, that was wonderful. Nearly all the projects which you so beautifully demonstrated were on existing buildings. Do you have much involvement with new buildings?
We do, but okay, so the problem for us is that there are many specialist providers of individual simple items, and lots of glass installations are very simple. So we can't compete cost-wise with folk who specialize in a very small area of endeavor. So there are lots of companies that just do glass balustrading. There are lots of companies that just do glass doors. Our niche is the fact that we do all of it, and the bigger niche is the fact that no one in this country has specialized in church structural glass, which doesn't sound like a big deal, but we've been doing it for about 10 years. And the reason that no one does it is because the lead times are very long. We're working on projects now that we started to work on up to 8 years ago. And so we have to be prepared to make the investment now, because the process is very complex. You have to produce the drawings for the design and a costing. That then has to go away to the Diocesan Architectural Committee, who then approve or otherwise comment on your design. That then is changed. It then goes off to the bishop, who grants what's called faculty, which is permission for the church to undertake that work. And only then does the church start to go out to get the funding to undertake the work. So that's why often there's very, very long lead times. and literally no one else has bothered. So that's why we've got this market.
What about planning permission?
Ourselves.
Planning permission required?
Often.
Listed building?
Yep. Listed building consent very often. And we have a pretty good relationship with Historic England generally, who like us because we're quite sensitive towards what we do.
Do you ever have to, you were talking about, you know, to stop people going into the glass. Do you kind of, I always hate seeing the plastic put onto the surface.
Yeah.
Do you ever work and look at how you can do designs with like sandblasting or adding other glass additions?
Okay, so the slight problem with doing that is that if you put a manifestation onto the glass at the point of manufacture, it really ties the hands of the installation team when they come to fit them. If you're putting in a pair of doors, it only needs a 1 or 2 mil misalignment between one door and the other, which is often necessary to get them to work properly because these buildings are rarely square, floors aren't flat, etc., etc. If there's any misalignment, you'll see it immediately if it's been sandblasted into the glass. On the other hand, applied manifestation, which is what you say you don't like, actually you can't tell the difference, and they come with a minimum 10-year guarantee, and you know you can sit there with your finger and try and peel them off. You can't get them off. They look just like sandblasting. So in fact, we never do sandblasted manifestations. We always do applied after the fact, because then you can get it perfectly aligned.
Yeah, I suppose because I'm one of those people who had to take all those manifestations off in a project. Because I did architectural glass as my background, and I just remember, it's kind of, it meets different requirements, but they're beautiful. They're beautiful to see the kind of contemporary and the old alongside. I'm sorry, I'm in darkness, but yeah, it's lovely to see.
Oh, thank you for saying that. I mean, these are things we do day in, day out. So I'm pleased to say that we're pretty good at it, and we've worked 6 times at the Tower of London. We've worked in many of the oldest churches in the country. We just finished a project in Canterbury Cathedral. We've just got a new one coming up at Rochester Cathedral. So, and many of the church architects around the country, most notable of which is Thomas.
I wanted to be seen.
They use us because they know they'll get what they're asking for. They know that we understand what the drawings mean and how we're going to produce them for them.
I think it'd be. I used to teach at Swansea.
Okay.
And I think this talk would be something that would be great for them to hear, because in terms of like when you're learning about stained glass and architectural glass and glass projects, they sometimes misunderstand the requirements when when you've got to do a new entrance.
Wow.
What I think David Proto has said it. You need to work with the architecture, but also the glass, the type of glass that's available now, rather than trying to squeeze something in that may not work.
Well, I understand what you're saying, but we would never do that. It has to meet the requirement.
Totally, yeah. I have always found it interesting with students where they kind of want to keep on doing this stained glass, and you're kind of saying, well, these lovely planar systems, there's these lovely fixings, these lovely sheets of plain glass that can give a beautiful aesthetic alongside an old building, and they don't necessarily investigate that. So it'd be great to more of that to go into when training glass artists about architectural commissions.
Peter, did you do the one at Westminster Abbey?
I actually don't know that. I don't think we did.
On the Great West Door?
I don't think so.
Oh, right.
I don't think so.
Two questions. Is it possible to polish out in situ scratches and stuff? That's question number one. And question number two, after 10 years or something. And question number two is how much movement, where you've got glass roofs going between two buildings, how much movement do those joints take?
Okay, so in answering your first question, it's perfectly possible to polish out glass scratches. And there are a number of specialist providers who do that. They use a particular paste and a polishing wheel, and it actually realigns the glass particles in such a way that the scratches just end up getting filled. So yes, it's perfectly possible to polish out scratches, subject to the depth. If it's seriously damaged, you can't, but most scratches you can. And in fact, you know, if
some panels start looking a bit tired after a few years because people look, you know, there's a number of scratches on them sometimes, and they get a bit not quite as clear because of the scratches.
Bit fogged.
Yeah. Well, what I would say to that is you need to be a bit careful, because glass polishing can easily run into hundreds, if not thousands of pounds, at which point you need to think about how expensive is it actually going to be to replace the glass, rather than, if you've got lots and lots of scratches, it's often much cheaper to replace the glass than it is to try and pay someone to polish them all out.
Okay.
What was your second question again?
Well, just the corollary to that first question. Do you have the data for all the panes of glass you produced? So if somebody rings you up and said you produced that lump of glass 10 years ago, can you recut it?
Yes. And in fact, one of the pictures I didn't show you is we put the glass around the staircase in Tate Britain, and it was the most complicated. We were the only company in Europe that they could find to produce this, and it was so complicated that we've kept all those drawings, because it was a 5-stage process to get it right, because it was so difficult. So yes, we keep all the drawings that we make.
Okay, so the second question was how much movement do those joints, where you've got pieces of glass between two buildings?
3 or 4 mil.
Okay.
You can.
Ooh.
They put it this way. We have no situations where the glass has either come adrift or leaked water after the fact. So the rubberized arbomeric is what it's called. The rubberized compound that you inject into the joins has quite a bit of flexibility in it. Yes.
No, it's an inch. It's 25 mil, and it can do, so it's like 15%, something like that. 20%.
Yeah, something like that. Yeah.
Okay, thanks.
That's all right.
Peter, is the lifetime expectancy of the structure limited to the lifetime of the bonding agent?
Interesting question. The only structure that could be relevant to, especially in what I've just shown you, would be that sloping roofed porch.
Mm-hmm.
Now, the glazing tape in that, I think I'm right in saying 3M put a 20-year guarantee. So most glass that we fit is fitted using mechanical fixings, unless the client asks otherwise. But technically, your answer is correct. It is limited by failure of the bonding agent, if that was what would happen. But hopefully, were that to occur, it would occur over a period of time. Someone would notice. And in fact, a couple of weeks ago, a couple of members of my team went out to an all-glass greenhouse, a semicircular greenhouse that we built about 6 years ago, and redid all the silicon. The client paid us, replaced a couple of hinges on the doors, and redid all the silicon between panels. So yes, technically you're right, yes.
Thank you. Thank you.
Bill?
A small question. I'm intrigued by your dovetailed joints. Do you have to manufacture the beams with the dovetailing bit in, or do you just do the joint and grind it away, or do you manufacture the beam and grind it away, or how's it done?
Okay, so toughened glass, and they normally are toughened, you can't touch it because the glass will explode.
Yeah.
So the dovetails have to be designed and built in. And in fact, in the example I used, the fins have a center beam which projects, and the beam a center panel which projects. The beam sits down over it like that. So these are outer panes of glass. This is the vertical center pane which projects, and the outer bit panels of the beam sit down over it like that. Yes, so that's how the dovetail works.
Right. Thanks.
And interestingly, it completely again meets all loading requirements.
Hello, Edgar.
And you use some sort of bonding material, or?
Well, normally, yes. We use a absolute clear silicon.
Yeah.
What's your favourite project you've worked on?
What's the light on?
Probably Take Britain.
Mm.
Certainly.
The challenge.
Yeah, it was certainly demanding. I mean, without going too far into it, we had drawings originally. We then went and produced wooden templates. Then we produced a second set of wooden templates because the structure moved, the stainless structure to which the glass is bonded moved. And then we made glass templates, and they were brought to site, and we sat there with a laptop computer and adjusted the drawings depending on, because the glass had to be 5 mil clear of all of the surrounding surfaces, including the stairs. Then the final glass was made. And in fact, we only got it onto site 3 days before Prince Charles turned up to open the building.
Wow.
Oh,
So
That was fun.
it was a bit nail biting, but yeah. We've never had to go back, and yeah, it was a tough call, but it was a very good project.
Have you got an exciting project on at the moment?
We've got a number of exciting projects on at the moment. The trouble is that I can't tell you about them because we have to sign NDA. But let's just say this: one of the glass panels we fitted very recently was 5 meters long, 2.7 meters high, 83 mil thick, and weighed 2 tons. One piece of glass. One piece of glass.
That wasn't the end of the swimming pool, was it?
It was. It was. Do you know whose pool it was now?
I don't know whose pool it was. I know where it is.
Do you?
You told us.
Oh, right.
It was
Okay.
down in Swanage.
No, it was at Rock.
Is where?
Rock.
Yeah.
It's in Swanage.
No, Rock.
So
Wow.
where do you get your glass made? Who makes it?
Lots of different companies make it. So because we're in the position we are, we actually broker the glass between competent, capable suppliers. I mean, when we're talking about that particular panel of glass, there are only 2 companies in the country that could make it. So brokering the glass in that instance becomes a bit of a joke, because it's either company A or company B, and whoever gives us the best price gets the job. But most of the time, we broker the glass between 4 or 5 different companies who will all vie on the basis of price and manufacturing lead times, and that's how we work. So we always have 10 to 15 projects on the go at the same time.
You said various suppliers.
Amazing, amazing. I'm sure.
So these are companies that do or make specialist glass
Yes.
panels.
Yes.
Yeah. Because they have to. Do they have to cast them?
No, they cut them from flat glass.
Right.
Using
And then
either-
they're heat treated.
afterwards they're toughened
Yes.
or laminated.
Yes.
But they
Yeah.
use water jet cutters mainly to cut the shapes of the glass, or automatic scribers. So they just scribe.
Yes.
I don't know if you've ever been to a glass factory, but they have wheels, computer driven wheels that just run over the glass and cut out the individual shapes, and they also optimize how they get the most return from each panel of glass.
Yes.
Well, it's been
Thank you.
absolutely
Amazing.
fascinating. I've thoroughly enjoyed it. I apologise for disappearing out of the picture for a few minutes, but it's my grandson's 21st birthday, and of course he phoned right in the middle of your talk, which was a bit frustrating. He's the one who is up at John's at Cambridge with the Abbott Scholar, which we support. Zach Lakota Baldwin.
Yes.
Yes.
We went to sort of visit him at John's a year or so ago. But it's his 21st today, and of course he chose right in the middle to phone, so I do apologise for disappearing, because I found it fascinating.
There you go then.
I think, I'm sure we could talk all night, but we're
still answering questions.
Yeah, the clock is ticking, ladies and gentlemen. Is anybody got any sort of last urgent questions, or I think the master can call an evening?
Any questions? Any questions? Any more questions?
No.
I have to say, Peter, this is the second time I've listened to you. Once at Guildhall, I think it was, and I have to say, on both occasions, fascinating. Really, very interesting. Having spent my working life in the glass industry, I've always wondered how these bits of glass, which I know not how to make, how they are produced, and what you've just shown. Very, very intricate cutting. Is any of it laser cut?
Yeah, not laser, water jet.
Only water jet.
Yeah.
Yeah.
Look, I think I'm right in saying most of the plants only have water jet cutters for cutting that sort of intricate glass. Yes.
Anyway, thank you so much indeed, and I would like to say a round of applause from everybody.
Thank you.
Yeah.
Thank you very much, Peter.
Okay.
Paul, back to you to wind us up or shut us down or whatever you do.
Well, I think another new adventure and a different aspect of glass.
Fantastic.
I think quite fascinating. I've had some new revelations of things that have happened today, which is exciting. We're probably going to have Max Jacquard, who was a arts and crafts winner, explain the glass that he makes next Thursday. I have told you that Christopher Maxwell's going to join us from New York on the 30th of July. And I've got some amusements and things coming up in August, which Demir is coming to me tomorrow, and we're going to take some photographs, and you will then learn about what we're going to do in August, which will be quite amusing and a bit of an adventure for you all to make an effort. Yes, Demir?
I just wondered, did you read all the books in your library?
Only you could come with a question like that. There's several of them been read, but there's several used for reference occasions. And they're not all about glass.
Good grief.
Thank goodness.
Shocking.
But I think on that note, everybody, I think we'll say good night and thank you so much for joining.
Good night, folks.
Thank you. Thank you, everybody.
Good night.
Bye.
Take care. Hopefully we'll see you at a dinner again soon, Peter.
Okay. Thanks.
Yeah,
Indeed.
thank you.
All right.
Thank
Take
you.
care, everybody. See you.
Peter, thank you.
Bye.
Bye.
Oh.
Bye.